Hello everyone and welcome back. I'm Mr. Cobalt, and in this video I'm going to do the second problem where you have an acid-base titration. So in my last problem I did the work but I erased it to kind of make it more clean. So here we have problem number 2. So we're going to treat this the same way. Again, you have, it's a little bit different. Now they're asking for like the volume of the titrant or the stuff that you are going to be titrating with. So in this case, they give you the volume of the acid, and they give you the volume um, and the molarity of the base that you titrated with, and they ask you to find the concentration of HCl. Here, they're giving you the concentration of the acid and the volume, and they want you to give, okay, if we're going to do a titration, what is the volume we would need in order to titrate this if we know the concentration of our NaOH. So it's a little bit different, but the way we're going to solve it is exactly the same. So we need to figure out where we're going to begin. So they're asking for a volume in milliliters, right? So we need to get to a volume in milliliters of this particular solution here. And they give us two concentrations, right? They give us molarity of NaOH and the molarity of HBr, and they give us volume of the HBr solution. So since the molarities we can use as conversion factors, we're not going to start with those. So the best way is to start with milliliters, because that is not related to anything and there's only one unit, and so that's a good indication that we're going to start here. Now, before we begin, we need to have a balanced equation. So we're going to have to write out the reaction between NaOH and HBr. So I'm going to write it up here. So because we have room, so we have HBr aqueous plus, and then we have the NaOH aqueous, and that's going to go to form products. And again, we figure out the products by doing the inside and the outside. So we're going to put the NaBr together. That's going to give you sodium bromide, and that's going to be aqueous. And then the H and the OH are going to go together, and that's going to form water again. Okay, so now we need to make sure this is balanced. The H and the OH go together to form water, so that is balanced. And we have one Na and one Br, and one Na and one Br. And so this is a balanced equation. So, and it's all 1 to 1. So now that we have our balanced equation, we're going to start with the volume of our HBr solution. So we're going to start here. We're going to have 35.00 milliliters of our HBr solution. We're going to put that over 1. Sorry about the squeakiness of the marker. So we're going to begin with there. And so we could use the molarity of HBr solution to convert from volume to moles of HBr, but we need liters. So again, we're going to need to use our milliliters to liters relationship. So again, I put the 1 with the unit that has the prefix, and the prefix multiplier goes with the base unit. So milli is 10 to the negative 3, so I'm going to write that there. So now I'm going to use that. So the milliliters goes on the bottom, so 1 milliliter goes on the bottom, and this is going to be 1 milliliter of HBr solution. And then liters goes on top, so this is going to be 10 to the negative 3rd liters of HBr solution. Milliliters of HBr solution are going to cancel out, and now I have liters of HBr solution. So now I can use molarity as a conversion factor. So I know the molarity is 0.140 molar. That means that I have 0.140 moles of HBr in 1 liter of the HBr solution. So I can use that as a conversion. So I have liters of HBr solution on top, so I want liters on the bottom. So 1 liter of HBr solution on the bottom and 0.140 moles, 140 moles of HBr on the top. So HBr solution cancels out. Now I have moles of HBr. Okay, so now I can go from moles of HBr to moles of my NaOH. So if I get moles of NaOH, then I can then use the molarity of the NaOH to convert moles to volume, which is what they want. They want a volume in milliliters. So then I'm going to use the mole ratio in my balanced equation, which is 1:1. So one mole of HBr on the bottom to cancel out with moles of HBr on top, and 1 mole of NaOH on top. So moles of HBr cancel out. I have moles of NaOH now. So now I can use my molarity as a conversion to go from moles to liters. So you can see here that for my NaOH, it's 0.200 moles of the NaOH is equal to 1 liter of the NaOH solution. So I can now use that as a conversion factor. So I'm going to put the I'm going to put the 0.200 moles of NaOH on the bottom to cancel out, and then 1 liter of the NaOH solution on top. So moles of NaOH cancels out with moles of NaOH. And now I have my volume of NaOH, but it's in liters. They're asking for milliliters. So now I have to use my equality again to convert from liters to milliliters. So I'm going to continue here. So I have liters on the top, so I want liters on the bottom. So 10 to the negative 3 liters of my NaOH solution. And then I'm going to have 1 milliliter on top. So 1 milliliter of my NaOH solution. So liters of my NaOH solution cancel out. And now I have milliliters of NaOH solution, which is what they're asking for. So I'm done with my conversions. So the only thing left is to multiply and calculate the answer, multiply and divide. So I'm going to multiply on the top, and anything on the bottom I'm going to divide by, ignoring the ones. So I have 35.00 multiplied by 1 times 10 to the negative 3 multiplied by 0.140. And then I have 1, 1, and 1, so I'm going to ignore those. Then I'm going to divide by 1, 1, 1, skip 1, 1, 0.2, divide by 0.200, and then I'm going to divide by that number there. So divide by 1 times 10 to the negative 3 equals, and I get 24.5. So That's going to give me 24.5 milliliters of the NaOH solution. Now I need to figure out the number of significant figures. So looking at everything, ignoring anything that's exact, so I don't need to worry about that. So milliliters to liters, ignore that. Milliliters to liters, ignore that. And then my mole to mole ratio, ignore that. So I have 3 sig figs here, 0.200, 3 sig figs here, 0.140, and I have 4 sig figs here. So my answer should be in the least number of sig figs, which is 3. So I have 3 sig figs, so this is my answer. So I need 2.45 milliliters of the NaOH solution to titrate and neutralize the 35 milliliters of the 0.140 molar solution that I have of the hydrobromic acid. Okay, so I hope this was helpful. I hope you enjoyed the video. If you like the video, like the video. Share it with your friends. Subscribe to the channel and make a comment in the comment section. Let me know what you think. And, ring the notification bell so you get notified of any new videos I put out. Thanks for joining me, and I'll see you next time.